Your medicine cabinet is full of drugs that started as weeds. Not metaphorically, literally. The chemistry inside certain plants was so precise that scientists reverse-engineered it into the pills you buy at the pharmacy today. So before you assume herbalism is just something your grandmother believed in, consider this. We're going to go through 20 plants, one by one, and show you exactly what compound does what, how it works in your body, and why the science actually holds up. No mysticism, no folklore. Just applied chemistry that's been sitting in gardens for thousands of years. Number 1. Aloe vera. Aloe vera, or Aloe barbadensis, has been sitting on windowsills so long that we stopped taking it seriously. Egyptian physicians were packing it onto burns and infected wounds thousands of years ago, and the reason it worked then is the same reason it works now. The gel contains a compound called asamanin, a long-chain polysaccharide that activates macrophages, your immune system's first responder cells, and it separately contains anthraquinones that punch holes in bacterial cell walls. So you're getting antimicrobial action and immune activation from the same clear gel. There's also an enzyme in there called bradykinase, which directly breaks down bradykinin, one of the main chemical signals your body fires to trigger pain and swelling at an injury site. Aloe isn't soothing in some vague way. It's interrupting a specific pain pathway. From a practical standpoint, the gel degrades fast once you cut the leaf, so fresh plant always beats anything in a bottle. Number 2. Frankincense. Boswellia serrata is a tree that grows in dry, rocky terrain across parts of India and the Middle East, and for millennia the resin it produces, frankincense, got burned in temples and credited with spiritual effects. The medical value was real, though. It just took a long time to find the mechanism. The resin contains boswellic acids, and one in particular, called AKBA, blocks an enzyme called 5-lipoxygenase. That enzyme produces leukotrienes, which are the chemical signals driving chronic inflammation in conditions like asthma, arthritis, and inflammatory bowel disease. Ibuprofen doesn't touch this pathway. It targets COX enzymes instead, so frankincense and ibuprofen are actually hitting different points in the same inflammatory cascade. Clinical trials on Boswellia extract for osteoarthritis showed measurable reductions in joint pain and better mobility. The priests burning this resin in enclosed spaces were probably inhaling therapeutic doses without any idea why they felt better. Number 3. Myrrh. Commiphora myrrh. A resin shows up in Egyptian embalming, Greek battlefield medicine, and Ayurvedic wound care, and historians spent a long time assuming the reverence was mostly symbolic, tied to its rarity and religious weight. The chemistry tells a different story. The resin is packed with terpenoids and sesquiterpenes, and a compound called curzarine disrupts bacterial membranes directly. Separately, myrrh contains compounds that block biofilm formation, which is the protective coating bacteria build to resist treatment. So it was doing real antimicrobial work on open wounds long before anyone had a word for infection. Animal studies also show myrrh activates opioid receptors at a low level, which explains why ancient physicians used it not just to clean wounds, but to dull pain during procedures. That's antimicrobial action and analgesia from one resin. Researchers are now looking at myrrh compounds as potential adjuncts to standard antibiotics, particularly against drug-resistant strains. Number 4. Sage. Salvia officinalis has been used as a memory aid since at least the Roman period, and for centuries that claim sat alongside a lot of folk medicine, interesting but hard to verify. Then researchers started looking closely at acetylcholinesterase, the enzyme that breaks down acetylcholine in the brain, and acetylcholine is the neurotransmitter most directly tied to memory formation and recall. Sage contains rosmarinic acid and a group of diterpenes, including carnosic acid, that inhibit acetylcholinesterase. That's the exact same mechanism used by prescription drugs for Alzheimer's patients today. So sage is hitting the same target, just at a lower dose and with a broader chemical profile. Clinical trials on healthy adults showed measurable improvements in word recall and attention after sage extract. and results in older adults with mild cognitive decline were even more consistent, which tells you the effect scales with how much the system needs support. From a practical standpoint, sage grown in well-drained, mineral-rich soil produces higher diterpene concentrations, so your growing conditions directly change what you're actually getting from the plant. Number 5. Thyme. Thymus vulgaris shows up in ancient Greek medicine, medieval European herbalism, and traditional Chinese practice, all for the same complaint: respiratory infections, bronchitis, coughs. That kind of cross-cultural consistency usually means something real is happening. The active compound is thymol, a phenolic monoterpene, and it's doing several jobs at once in your airways. It kills the bacteria most responsible for respiratory infections, relaxes the smooth muscle in your airway walls so breathing gets easier, and loosens mucus so you can clear it. Germany's Commission E, the European body that formally evaluates herbal medicines, approved thyme preparations for bronchitis and randomized controlled trials comparing thyme ivy syrup directly against standard expectorant drugs showed equivalent outcomes for acute bronchitis. Thymol is also the active ingredient in Listerine. Pharmaceutical companies have been extracting and using plant compounds this whole time. They just don't advertise where the chemistry originated. Fresh thyme carries higher thymol levels than dried, and the essential oil is far more concentrated than either. Number 6. Basil. Most people think of Ocimum basilicum as a kitchen herb, something you tear over tomatoes, and that framing has buried a genuinely interesting pharmacological profile. The essential oil contains eugenol and linalool, both of which have direct antimicrobial activity against food-borne pathogens like E. coli and Staphylococcus aureus. The reason basil got paired with fresh and fermented foods across so many cultures wasn't just taste, it was chemistry doing preservation work nobody had named yet. But separately from that, basil extracts inhibit an enzyme called alpha-glucosidase, which breaks down complex carbohydrates into glucose in your digestive tract. That's the same target as acarbose, a pharmaceutical drug used to manage blood sugar in type 2 diabetes. The flavonoids orientin and vicinin go further, protecting the pancreatic beta cells that produce insulin by reducing oxidative stress on them directly. So the plant is supporting blood sugar regulation from two different angles at once. Number 7. Turmeric. Turmeric became a Western wellness trend, and that's actually what buried the interesting part of the story. The spice aisle version skips the chemistry entirely. Curcumin, the active compound in curcuma longa, works upstream from most anti-inflammatory drugs. Instead of blocking a single enzyme, it modulates NFKB, a regulatory protein that controls which inflammation genes switch on in the first place. That's a broader target than ibuprofen ever touches. Pharmaceutical companies ran hundreds of trials trying to develop curcumin-based drugs, and the problem wasn't whether it worked. Bioavailability killed every attempt, because curcumin absorbs poorly on its own. Traditional Ayurvedic preparations always combine turmeric with black pepper, and piperine in black pepper increases curcumin absorption by up to 2,000%. Ancient practitioners solved a pharmacokinetics problem that researchers had to rediscover from scratch. If you're growing turmeric, it needs warm soil, steady moisture, and a long season to build meaningful curcuminoid levels in the rhizome. Number 8. Ginger. Zingiber officinale has been the go-to remedy for nausea across so many cultures and centuries that it's easy to write off as folk medicine. The clinical data says otherwise, and it's some of the strongest we have for any plant on this list. Gingerols and shogaols, the active compounds in the rhizome, block 5-HT3 serotonin receptors in the gut. That's the exact same receptor targeted by ondansetron, a pharmaceutical drug prescribed for chemotherapy-induced nausea. Ginger also slows gastric movement in a way that reduces the signals that trigger vomiting. Meta-analyses of randomized controlled trials confirm it works for pregnancy nausea, post-operative nausea, and motion sickness, with effect sizes comparable to standard antiemetic drugs. Gingerols also inhibit COX-2 enzymes, which puts them in the same category as anti-inflammatory drugs. So the traditional use for joint pain has a real mechanism behind it too. Fresh ginger carries more gingerols, but drying converts them into shogaols, which have a different potency profile depending on what you're treating. Number 9. Garlic. Egyptian workers building the pyramids got garlic as part of their daily ration. Roman soldiers carried it on campaigns. Medieval physicians prescribed it for infections and heart complaints. For a long time, historians filed that away as cultural habit rather than evidence of anything real. When you crush a clove of Allium sativum, you trigger a chemical reaction. Alliin, an amino acid stored in the cell, contacts alliinase, an enzyme stored separately, and together they produce allicin, a sulfur compound with direct antimicrobial activity against bacteria, fungi, and some viruses. But the reaction needs a few minutes to complete, and heat destroys the enzyme entirely. So raw garlic prepared correctly is pharmacologically different from cooked garlic. On the cardiovascular side, meta-analyses confirm that regular garlic consumption produces modest but real reductions in systolic blood pressure through nitric oxide production in blood vessel walls. Allicin doesn't survive commercial processing, so that capsule of garlic powder almost certainly isn't delivering what the fresh plant research actually shows. Number 10. Mint. Mentha piperita feels cool on your skin without actually being cold, and that's not a trick of perception. It's a specific receptor firing. Menthol activates TRPM8 channels, which are the same cold-sensitive nerve signals triggered by actual low temperatures. So your brain receives a cooling message from a plant compound rather than a drop in temperature. In your digestive tract, menthol blocks calcium channels in the smooth muscle of your intestinal wall, relaxing it directly. That's why enteric-coated peppermint oil capsules are used clinically for irritable bowel syndrome, with trial results showing pain reduction comparable to prescription antispasmodic drugs. Topically, that same cold receptor activation competes with incoming pain signals along the same nerve pathways, effectively crowding them out. That's gate control pain theory in action, and it's why menthol sits on the active ingredient list of most pharmacy pain creams you can buy right now. Number 11. Lavender. Lavender got absorbed into bath product marketing so completely that most people stopped asking what it actually does in the body. Linalool, the primary terpene in Lavandula angustifolia, modulates GABA-A receptors, which are the same receptors targeted by prescription anti-anxiety drugs like diazepam. That's not a loose association, it's the same molecular address. A standardized oral lavender oil preparation called Silexin has been through multiple randomized controlled trials for generalized anxiety disorder, and results showed anxiety reduction comparable to lorazepam without the cognitive impairment or the withdrawal profile that makes benzodiazepines so problematic long-term. Inhaled linalool also produces measurable changes, with studies showing reduced salivary cortisol and shifted heart rate variability in stressed subjects. So the olfactory route is delivering pharmacologically active doses, not just triggering a memory of feeling relaxed. Flowers harvested just before full bloom carry the highest linalool levels, so what you grow yourself and what's in a cheap commercial product aren't the same thing pharmacologically. Number 12. Chamomile. Most people drink chamomile tea when they can't sleep and assume it's working through some general calming effect. It's more specific than that. Matricaria chamomilla contains a flavonoid called apigenin, which crosses the blood-brain barrier and binds directly to benzodiazepine receptors, the same receptors targeted by prescription sleep aids. But apigenin binds with lower affinity than pharmaceutical benzodiazepines, so it nudges those receptors rather than overriding them, which is why you don't wake up groggy and why there's no dependency risk. The essential oil fraction is doing something completely separate. Alpha-bisabolol and chamazoline have direct anti-inflammatory activity, with chamazoline specifically inhibiting leukotriene synthesis in skin tissue, which is why chamomile extract shows up in so many dermatological products. A chamomile tea and a chamomile essential oil aren't doing the same thing pharmacologically. Chamazoline doesn't even exist in the raw plant. It forms from a precursor called matricine during steam distillation. Number 13. Ashwagandha. The word adaptogen gets slapped on so many supplements that it's basically lost its meaning. So let's talk about what Withania somnifera actually does, because the mechanism is specific enough to be worth understanding. The active compounds are withanolides, concentrated in the root, and they work on your HPA axis, which is the hormonal feedback system that decides how hard your body reacts to stress. It's not blocking cortisol outright. It's recalibrating how sensitive that system is to perceived threats in the first place. Randomized controlled trials on chronically stressed adults taking standardized root extract showed measurable drops in serum cortisol, better sleep, and improved stress scores, with effect sizes large enough to matter clinically. Separate trials on physical performance showed real gains in strength and recovery, which is an unusual combination for a single plant. A loose root powder with no withanolide percentage on the label isn't what those trials tested. Number 14. Holy basil. Ocimum tenuiflorum tulsi isn't the same plant as the basil you cook with. The phytochemical profile is different enough that the two share almost no therapeutic overlap. Tulsi contains ocimumicides A and B, compounds specific to this species, and they've shown adaptogenic activity in animal models by normalizing stress-driven changes in dopamine and serotonin levels. That's a different target than ashwagandha's cortisol pathway, so these two plants are working on separate parts of the same stress response. Ursolic acid in tulsi inhibits both COX-1 and COX-2 enzymes, which puts it squarely in NSAID territory for anti-inflammatory action. Clinical trials in type 2 diabetic patients taking tulsi leaf extract showed improvements in fasting blood glucose and lipid profiles, so the metabolic effects are real and documented. Tulsi also does something unusual under mild growing stress. It concentrates its essential oils rather than depleting them, so a slightly tough environment actually improves what you harvest. Number 15. Neem. When a single plant gets credited with treating skin infections, malaria, diabetes, and dental disease all at once, a skeptic's instinct is to dismiss the whole list. With Azadirachta indica, that instinct leads you to the wrong conclusion. Neem contains over 150 identified bioactive compounds, and they're not all doing the same job. Nimbidine and nimbin have documented anti-inflammatory activity in animal models. Gadunine shows antimalarial activity through a mechanism completely separate from other known antimalarial compounds, targeting parasite protein folding directly. The dental application is probably the best documented. Clinical trials confirm that neem twig chewing sticks reduce plaque and gingivitis at rates comparable to chlorhexidine mouthwash, because the woody tissue concentrates antibacterial compounds that break down the cell membranes of the bacteria driving gum disease. India's been using neem twigs as toothbrushes for thousands of years, and the trial data simply confirmed what daily practice already showed. One caution worth knowing: high-dose internal use carries documented liver toxicity concerns, so the part of the tree and the dose both matter here. Number 16. Echinacea. Echinacea is the best-selling medicinal herb in the Western market, and the popular claim that it boosts your immune system is not quite what the research shows. The active compounds, alkylamides, caffeic acid derivatives, and polysaccharides don't just crank up immune activity across the board. They regulate it, activating macrophages and natural killer cells while also reducing inflammation. The alkylamides specifically bind to CB2 receptors, which are cannabinoid receptors on immune cells, and nobody saw that coming because nobody was looking at cannabinoid pathways in a plant with no connection to cannabis. Meta-analyses confirm echinacea reduces cold incidence and shortens duration, but the effect depends entirely on which species you're using and which plant part went into the preparation. The three main species have different phytochemical profiles, so a trial on one doesn't tell you anything about another. Roots need 3 to 4 years of growth before alkylamide levels reach therapeutic concentrations. Number 17. Ginseng. Panax ginseng has been used in Chinese and Korean medicine for over 2,000 years as a tonic for energy and cognition, and it's been studied more extensively than almost any other herb on this list, so we actually have data to work with rather than just tradition. The active compounds are ginsenosides, a class of triterpenoid saponins, and different ginsenosides do different things. Some are stimulatory, some are inhibitory, so ginseng doesn't behave like caffeine. It's modulating multiple systems at once, which is why the effect feels balanced rather than sharp. Clinical trials show improvements in working memory and reaction time in healthy adults, and the results are even more pronounced in older adults with mild cognitive decline, suggesting the benefit scales with how stressed the system already is. Growing it yourself means committing to a realistic timeline, 4 to 6 years minimum before the root builds ginsenoside levels that actually matter therapeutically. Number 18, fennel. Feniculum vulgar shows up as a digestive remedy in Mediterranean, Middle Eastern, and South Asian medicine going back thousands of years, and the carminative effect is well supported. Anethole, the main compound in fennel's essential oil, relaxes smooth muscle in the gastrointestinal tract by modulating calcium channels, reducing spasms and gas. That part most people know. What most people don't know is that anethole's derivatives, dianethole and photoanethole, bind weakly to estrogen receptors in the body. That's why fennel shows up historically for stimulating milk production in nursing mothers and regulating menstrual cycles. Those aren't two separate folk traditions accidentally attached to the same plant, they're two applications of the same phytochemical profile. The estrogenic activity is weak compared to actual estrogen, but it's pharmacologically real, so concentrated fennel essential oil needs careful consideration for anyone managing a hormone-sensitive condition. Seeds carry the highest anethole concentration, and a tea is a much gentler preparation than the oil. Number 19. Dill. Anethum graveolens is probably the least glamorous plant on this list, and it's been sitting in pickle jars so long that most people never thought to ask why it ended up there. The reason is carvone and limonene, the primary volatile compounds in dill's essential oil, both of which have documented antimicrobial activity against the bacteria and fungi that cause food spoilage. People were adding dill to fermented foods long before anyone knew what bacteria were, because the chemistry was doing real preservation work. The flavor was a side effect. Beyond food safety, dill seed extracts have shown activity against Candida species, and the essential oil has been tested against antibiotic-resistant bacterial strains as a potential adjunct to conventional treatment. Separately, flavonoids like kaempferol and quercetin in dill inhibit COX enzymes, giving it genuine anti-inflammatory activity, and its carminative compounds relax intestinal smooth muscle through a different chemical pathway than fennel uses to do the same job. Number 20, rosemary. Rosmarinus officinalis contains two diterpenes, carnosic acid and carnosol, that cross the blood-brain barrier and activate something called the NRF2 pathway. That pathway is basically a switch that tells your cells to start producing their own antioxidant enzymes. So instead of just delivering antioxidants directly, rosemary is triggering your internal defense system to run harder. Animal models have shown rosemary extracts protecting dopaminergic neurons, which are the specific neurons that die in Parkinson's disease, and the proposed mechanism runs straight through that NRF2 activation. Rosmarinic acid in rosemary also inhibits acetylcholinesterase, the same enzyme sage targets for cognitive support, so you're getting two separate brain protective pathways from one plant. Ancient Greek students wore rosemary garlands during exams, and that tradition shows up again in Shakespeare. It wasn't poetry. It was observation, built up over generations of people noticing that something in this plant was doing something real for memory. And the phytochemistry is now catching up to what they already knew. Every herb on this list followed the same arc. Traditional practitioners noticed an effect, used it for generations, and eventually a lab found the compound, identified the receptor, and confirmed the mechanism. Estimates suggest that somewhere between 40 and 70% of modern medicines trace back directly to plants used in traditional medicine systems. That's not a coincidence, that's a track record. But knowing the plant isn't enough. Growing conditions change the concentration of active compounds, and a weak preparation isn't the same thing the research tested. Subscribe, because we're going deeper into the applied science of plants that actually do something,